All right, let's talk about absolute value and how we solve absolute value equations. Absolute value is the distance from zero on a number line. Absolute value is always positive. Keep that in mind as we look at examples. So, the absolute value of 2 is 2, because 2 would be 2 spots away from 0 on the number line. And the absolute value of negative 2 is also 2. So, what has the absolute value of 2? Well, both of these gave us the absolute value of 2. So, for that reason, when we solve an absolute value equation, once we have the absolute value isolated by itself on one side of the equal sign, whether it's just x like this, or it could be a binomial, but as long as what is in the absolute value bars is isolated, we make two equations. We drop the bars and we set it equal to the positive version of what's on the right and the negative version of what's on the right. So, again, like we talked about, what would give us an absolute value of 5? Both positive 5 and negative 5. And so we put this in a solution set. It doesn't matter which order they go in, at least in the ALEKS program. So again, we're going to isolate the absolute value, which could be just an x, or it could be a binomial. And then we drop the absolute value bars, set it equal to the positive version of what we had on the right and the negative version. So here we would be done. Let's look at some examples from the homework. 1.6, if you're in my Fall 23 AIM course. So again, we want to isolate what's right here. So we're just going to subtract 3 from both sides. So now the absolute value of x equals 2. We have isolated the absolute value, so we drop the bars, set it equal to positive 2 and negative 2. And then we're done. So on the test, this would be fine, but in ALEKS, you actually click the solution set button and put in your answers. You might get one like this. Remember that absolute value is always positive. If we isolate the absolute value here, 2 minus 13 is negative 11. Absolute value is always positive. So if you end up with absolute value isolated equals to a negative number, stop here. You're done. Because there is no solution. And in ALEKS, you click the empty set. It's kind of like a long squiggly bracket. Empty set. Or a null set, N-U-L-L. Here's one with a binomial inside the absolute value bracket. If there were a plus 3 beyond the absolute value bar, we would, subtract 3 first. We don't subtract this 1 because we want to isolate what is in the absolute value bracket. And so we set it equal to the positive version and the negative version. And now we just have two small equations to solve. Subtract 1 from both sides. Hello, kitty. Divide 2 by both sides. We get x equals 2. This is just solving a simple equation here. Subtract 1 from both sides to get negative 6. And divide to get negative 3. I know this homework assignment is kind of grouped with the inequalities. We're not putting this on a number line or anything. This is, we have solved. So we put our answers in a solution set. Now, number 6 is the one that students are asking me about. So we'll take a look at this one. There's a few things happening to the absolute value bars. There's this 3 on the outside that's being multiplied, and then there's a plus 7. You might be tempted to distribute this 3, but we don't. Again, the goal is to isolate the absolute value. I call them bars because they kind of extend vertically. But the 3 is not inside the absolute value. So, just like solving an equation, we want to divide out the coefficient last. So first I'm going to subtract the 7 to get rid of it. Now I have 3 times the absolute value of 3x plus 3 equals 16 minus 7 is 9. And we divide out this 3. Anything we do to one side of the equation, we do to the other. So it just cancels out on the left. Now we have the absolute value of 3x plus 3 equals 3. So that is how we get this work down to isolating the absolute value piece. Now we set up our two equations. Drop the absolute value bar, set it equal to positive 3, and set it equal to negative 3. We'll get 0 here as we subtract the 3. And if you get 0 as an answer, that's fine. Students sometimes confuse 0 with no solution, but 0 is our first solution. As I subtract 3 over here, negative 3 minus 3 combines into negative 6. Divide out the coefficient. And those are the two answers. Negative 2 and 0. So that's as hard as the absolute value equations get. But let me know if you have any questions.